G'day, it's Alex here again, Victor Kilo 2 Papa Radio Charlie. I've got another Clansman here on the bench today. This particular Clansman is suffering from a very typical fault that many people out there have probably experienced with their Clansmans. This particular fault in many cases leads to complete failure of the radio. It's to do with the audio, and it's to do with what we call the audio wobble. One of the fatal problems with the Clansman is some of them develop an audio wobble. Okay, so before we go into what causes the audio wobble, let's have a bit of a listen to an audio wobble. It's easily recognised by tuning into a local station, something strong, and having a listen to it, and you'll hear the audio of the receive wobbling all over the place. You try to transmit, and you'll get complaints that there's something wrong with your audio. It's all wobbly. Okay, so today I've got the RF generator there out of the ARC, set on about 14 megahertz. We'll turn the radio on and let's have a bit of a listen to typically a typical audio wobble. Hear the wobble? Okay, that's a typical audio wobble, and yep, it's one of those things that many people get with a Clansman over time, and there's been various people with various suggestions on what to do about an audio wobble. So what we're going to do now that you understand what I'm talking about with the audio wobble, we're going to go and have a look at the circuit diagram and see what actually goes on in the radio, how it works, and the possible causes of the audio wobble. Okay, here we are on the looking on the computer monitor at the line diagram of our Clansman 320. So let's have a little bit of a look at the story, the likely suspects, and what it's all about. Our story begins here with the power supply. Okay, this is unit 5. You'll see here on the power supply there's an inverter that changes 12 volts to 110 volts. There's another section here called series stabilizer, which is a regulator. Okay, our 110 volts comes out. Here it is there, and it goes down to our unit 9, I should say, the synthesizer. Okay, and down here we've got the decade switches for our frequency selection on the front panel. Okay, so this is a DC supply, 110 volt DC supply that comes to the synthesizer. And what the synthesizer does with that, it's got a choice of sending any voltage between about 5 and 85, and it sends that voltage up to, or depending on the frequency that we select, it sends it up to the 3H board, and the 3H board is situated on the turret of the 320. And in the 3H board on the turret, there's the variable frequency oscillator. So depending on the voltage that's applied by the synthesizer to the 3H board, so we get a frequency generated out of the variable frequency oscillator, and this is the main frequency for transmission and receiving. So let's have a look at the transmission side. So the transmission side comes out of here, and it goes up to the 6 board. I think it's 6E on the main motherboard. Okay, so and off to transmission from there. The receive side is another supply that comes off the same place, and that goes down and across to the receive section, which is the 3A board on the turret as well. So this looks after the receive. So it goes without saying that if the 3H board, where'd it go? There it is. So if the 3H board was to vary the frequency, it would vary for both transmission and receiving. Okay. So also what happens here is there's a check voltage, this one here. It goes back, or check frequency I should say, it goes back to the synthesizer. The synthesizer looks at that and decides whether the 3H board's doing the right thing as far as the correct frequency. And if it checks the check signal and it decides it's not doing the right thing, it varies the DC reference voltage back up to the 3H board. And the 3H board reacts and changes. It changes it for the transmit and it changes it for the receive. And then that is checked in again by the synthesizer down here, who may decide that it overreacted. So it'll vary the DC voltage again, and the 3H board will react again. So in essence, the wobble in our radio is this thing deciding that this thing here is not doing the right thing and telling it constantly to change. Yeah, so who's at fault? Is the fault up here with the 3H board, or is the fault down here with the synthesizer? What comes first, the chicken or the egg? Who knows? So constantly the DC voltage here, the control voltage, if that's wobbling, then the whole system's going to be a wobbling system. Okay, so let's go and have a look where all this DC begins and where these problems could very well be. And the first culprit in our chain of events is the power supply, unit 5. And we've all heard the stories about the capacitors on unit 5. Okay, the high voltage capacitors, and there's two of them that live on the 110 volt supply. I think there's C8 and C6, I think. They're the only two electrolytics or tantalum capacitors that are on the power supply. And they should be changed without saying, because age becomes weary, and weary becomes inactive, and rhubarb. So for maintenance, simply those two capacitors are always changed, and we've all heard that 1,000 times that you need to do that. Okay, but down here on the synthesizer, where the 110 volt goes into the synthesizer, on the top board of the synthesizer lives two more capacitors, and they're about 10 microfarad capacitors, and they get old and weary as well, two tantalums. And when we change the two on the power supply, it's always recommended to change the two on here. Okay, and they're the smoothing capacitors for the 110 volt supply. Okay, and in many cases we do this maintenance, and all of a sudden our wobble's gone, and life is good again, the Clansman's doing its job, etc., etc. Another problem that can occur up here is the regulator, the series stabilizer on here. So, as a matter of fact, if the 6 volt's not right, and you don't get enough 6 volts, and you don't get enough 12 volts, etc., etc., down here earlier on the power supply, you may not get enough voltage here for the series stabilizer to operate and actually regulate the voltage. So you need to be looking at the voltage coming out of your power supply and make sure it's a stabilized voltage around 110 volts. So there's a little twiddle adjustment, there it is right there, and as you move that up, the voltage will slowly increase and decrease when you move it back down again, and it's recommended to have it about 110 volts. If you get up to say 100 volts or 104 volts and you twiddle it some more and it doesn't go up anymore, then I'd be looking earlier in the power supply down here to see if there's enough voltage to activate the inverter to give the stabilized voltage over here. So a good place to start is your power supply. And one of the best ways to eliminate the power supply is to substitute it with a known good one. Okay, so a bit of a story about the power supply. So if we go through all of that and we can't find any problems and we still have the persistent wobble, okay, we move further down here to the synthesizer area. Okay, and this is a bit of a taboo area, this one. The synthesizer's one of those things that when it fails, it virtually can't be pulled apart and repaired by just people like me and you. Maybe the army did it, I don't know. I would suggest it was just simply changed out, okay, and possibly went back to the manufacturer to repair. It's a very complicated arrangements of stacked little boards with interconnecting buzz bars, touch things, static electricity, components fail, rhubarb. It's a danger area, this one. And in many cases, when this dies, the whole radio is ended. It's all over. Good night, nurse. Okay, so yeah. So what we're going to actually do is we're going to try and find out whether it's the synthesizer next that's causing the problem, or it's in fact up here in our 3H board, the variable frequency oscillator. So remember that these two are operating in a loop. The DC supplied, this generates the frequency, it's checked and varies the DC supply, and round it goes to up and down, wobble. Okay, so what we're going to do now is we're going to look at how that we're going to diagnose whether the problem is in the synthesizer or in the 3H board. So let's look at the DC supply coming out of the synthesizer. Up it goes here to the 3H board, and it also goes across to the varicaps in the receive board. Okay, so in actual fact, the way that the wire is routed is it comes from here, it goes up to the 3H board, and in real life loops from this 3H board straight to the 3A board. Okay, so when you look at the connection that in the 3H board that the DC supply comes up into, it's a real bugger of a place to get to and to disconnect. Remember, it's a screened cable as well. And look, in my personal opinion, it's really difficult to get at the connection in the 3H board physically. Okay, it's a pain in the neck as far as I'm concerned. So what I'm going to suggest here is we're going to open up this particular loop between the synthesizer and the 3A board, and we're going to try and find out which one of these two components is giving us a problem. So this is how I do it. I don't know about other people, but this is how I do it. First of all, I dial myself up a known frequency, and let's just pick, for example, 14 megahertz. So we get the radio operating on 14 megahertz. Then I go up here to the 3H board, and I measure the voltage that's been sent up here by the synthesizer. And I know from experience it's going to be around about 14 to 15 volts DC. So I get that value, I measure it, and I write it down on a piece of paper. Okay, and then what I'm going to do is to go to the rear of the synthesizer, and I find it's difficult to get to as well, but it's one of those things you're going to have to do. A lot of people move this particular synthesizer into what they call the service position. Other people, they try to jam tools down behind and disconnect this terminal here on the synthesizer, and in my opinion it's not enough space in behind it to do that. So what I'm going to actually do is I'm going to undo the mounting bracket for the synthesizer, move the synthesizer out so I can get access to this terminal. I'm going to disconnect the wire, and I'm going to solder a new wire out, a little pigtail sticking out, and I'm going to solder another little pigtail sticking out. I'm going to bring those two pigtails out so that I can either connect them physically or disconnect them. Okay, and then I'm going to put the synthesizer back in place. I'm going to put the back of the radio back together again, and then I'm going to connect those two wires back together again. I'm going to start up the radio. Again, I'm going to check the voltage that's being supplied up here, and it'll be around about 14.5, 15 volts. And then I'm going to disconnect the wire, and I'm going to apply a separate DC smooth supply to the 3H board. Okay, so in other words, the 3H board is going to be looking at a separate DC supply for that frequency. Now, here's the telling part. If the wobble stops, it means that the 3H board is operating as it should, and it's not causing the wobble. If the wobble continues, then the 3H board is the culprit. So if the 3H board stops wobbling and our problem goes away, then the problem is in the synthesizer. It's as simple as that. And if it's in the synthesizer, it's bad news. Bad news. But let's not prophesize the bad news yet. Let's actually go to the set and do exactly what I've just suggested and get to the bottom of our wobbly signal. I can tell you at this point I've already been down the road of checking the power supply and it's operating perfectly. The capacitors have been changed, they're brand new. The capacitors on the synthesizer are brand new as well, the ones that are situated on the top board. So all that maintenance has already been done. Okay, so let's head for the radio and get it all happening, guys. Okay, we're back in the workshop. I mentioned before about the 110 volt supply being, the main issue when it comes to wobbliness. So we need to make sure that that's all right. And as I suggested, I changed the capacitors on the power supply, and here's the synthesizer. And on the top board, just under there's two capacitors, and they're the ones 10 microfarad. They're the ones that have to be changed. So let's just have a look at what to expect from a good power supply here. We've got the 110 volts, and on this is the output of the 110 that goes to the synthesizer. And over here we've got 121 volts just there, 121. That's the unregulated side. We need 121 volts on the unregulated side to get 110 on the regulated side. So if you measure your power supply after you've done the upgrade and and you want to adjust it, I think there's a potentiometer down here underneath there that you do to adjust the 110 volts. But you actually need 121 on the unregulated side to get that 110 volts. So if you're not getting 121 volts there, you need to be looking earlier in the power supply on the other side of the little transformer. The voltage, I think it's the 6 volt side there that needs to be perhaps beefed up a little bit. So yeah, I'll be checking up here. There's a 6 volt test terminal there. You might find it needs to be beefed up a little bit to get the voltage out of this side. It's a little oscillator, oscillating transformer. So I'm going to turn the radio on, and we're going to watch the 110 build up. It's a bit hard to turn it on and have the meter on there at the same time, but I'll be as quick as I can. So now I'm putting it on there. So let's have a look at the voltage. See it building up there? Yep, that's the capacitors charging up. And that should come up to nice little 110 volts. Okay, and the capacitors are charged up. There it is. There, sitting there nicely. And if I go onto the 121 volt side, there's the 121 volt side, so I've got that happening as well. Okay, so my power supply, as I said, I'm very, very confident that it's working extremely well. As I say, it regulates properly. The capacitors have been changed, so we'll move on and we'll do the tests that I suggested when we looked at the line diagram. Okay, on this particular radio here, I've already removed the tuning section. Really not necessary. We could be taking this DC reading from behind the synthesizer when we get it off, but because I've got this particular radio stripped down to this stage, why not take it here? If you wanted to remove the tuning section, it's really easy. There's just 4 screws, 1 wire to unsolder, a nut to come off, and a little knob at the front, and the whole thing comes off. And then there's 4 studs. You just undo the 4 studs and they remove as well. Then you take the cover off the 3. By the way, that's the 3H board. That's the variable frequency oscillator, and this is the 3A board, which is the tuner. Okay, so that's the DC supply cable that's going across. So it comes up and it comes to the 3H board and then jumps across to the 3A board, and that's the difficult section there that I mentioned. I don't want to disconnect it there. So let's just go on to the point here on the 3A board and measure our DC supply. So I'm on there at the moment, and that happens to be 15.28 volts. So that's 15.28 volts for the frequency that's selected on the front dial. I think it's 14 megahertz or something. So what we're going to do is we're going to disconnect this particular wire here from behind the synthesizer, and we're going to inject 15.28 volts in, and we're going to see what happens to the wobble. So let's get in behind that synthesizer. And by the way, I was saying before that, that it's very close in behind the synthesizer, and if you look at it here, the wire that we're talking about is right down inside there, yeah. And look, at this point, I'll tell you the story about these radios and the wobble. So where do these radios with the wobble come from? Okay, I'll tell you exactly where they come from. You know these people that sell radios on eBay, whether they're suppliers, but a lot of the private guys, you buy them off, unable to test. Bought it, never tried it. It probably works okay, but never had it on the air. These are the type of alarm bells that should be going off when you're buying one of these radios. If you're going to buy one of these untested, unable to test type of radios, be prepared to end up with one that doesn't work or it wobbles. This particular radio here that I bought, it was a typical unable to test. Last bloke that had it worked fine. It's here, mate. You want it? Okay. It's this price, and if you don't buy it, someone else is already on the phone, and they want it. Okay. Yeah, these are the typical type of things you get. But look, I bought this one as a project. I knew it was going to be like this. I bought this one as a project to work on. So there you go. Okay, so when I got it, what did I find? I found out it had no 3-volt power supply. Why didn't it have a 3-volt power supply? Because someone had jammed something down behind the synthesizer here, shorted the pin, the 3-volt pin to ground, and actually bent it. It was still touching the ground, and blew up the power supply, the 3-volt supply. So I fixed the power supply, found out the problem, why it had blown. The pin was shorted to earth, bent it back again, got that working. No audio. Went underneath, so I started searching through and found a dry joint on the motherboard, on the 6 motherboard, and then we're up to the stage of the wobble. So this is basically what's happened here. Okay, so all that aside, let's get into this thing and get the synthesizer out of the way so we can get access behind there. So let's do that now. Back's been removed, and in order to clear the number 6 motherboard out from underneath, so we can get access behind the synthesizer brackets to take the screws out. It's simply a matter of taking these screws out with the green circles around them. Yeah, they're a dead giveaway. There's one there as well. Okay, so after we've got those ones out of the way, I'll turn the radio upside down. We'll have a look underneath. You'll see the motherboard there, and lo and behold, it's got a whole host of screws that hold it in as well. All got green circles around them. Yep, okay, so we remove all those. Once we get that removed, we just gently pull up at the back, and the metal sections here will come apart, and then we're going to lift up the number 6 board so it's hinged up like that. Put a screwdriver underneath to keep it up there, and that'll give us access to the screws that hold the synthesizer bracket in. Okay, all of the screws have been removed, and as advertised, there's the motherboard suspended up with a screwdriver. If you look, we've got more screws with green holes around them, green circles around them. There's that one there, this one here, that one there, and lo and behold, there's a missing one there. Someone's been here before, yeah, and they've got parts left over now. Okay, lucky I've got enough spares here to return a screw into there when I'm finished. But if ever you see in the text, move the synthesizer out to the service position, you see the arrows? You can undo the screws, pull, or you've got to take these 2 off here on the side too, by the way, those 2 there. They also hold the synthesizer in as well. So yeah, you can undo all those screws, you can pull the whole section out, moves out about that far. In fact, it moves out exactly that far. And you put the screws back in over here, and it re-secures the synthesizer out in what they call the service position, which gives you access to the rear connections. But to tell you the truth, it's still pretty cramped in there, even in the service position. So let's get those out, and let's get some access into the back of the synthesizer. Well, there it is. The synthesizer's been pulled out of the way, and I've tilted it a little bit to give us access. And if you look down in the back there, on this side, you'll see the terminals. Yeah, that in fact, that one there, the top one, that was a 3-volt one that was bent to earth that I found before. But below it, there's a black one and a pink one. And I've got the meter connected to the other end over here where we were before, just to make sure I'm on the right wire. And if we look down on that pink one just there, got the meter connected to it. It's hard to do this while holding the... Okay, there it is. Yeah. So that's actually that one there, that pink one there. So we're going to unsolder that. We're going to solder a little flying lead, bring it up here. We're going to solder another little flying lead to the cable and bring it up there. And we'll be able to connect them together with the synthesizer back in position. So we can run the radio and have the pleasure of being able to disconnect that, reconnect it, and put an external DC supply onto the tuning section. So there we go. Right, I've managed to do the intricate soldering job. I've soldered the a little blue wire going over here to the 3A and 3H board, and I've soldered the red wire onto the synthesizer. So what we're going to do is put it all back together again. We'll put these back together, we'll get the radio operating back as it was before, and then we'll see about disconnecting that and injecting the separate DC supply in and see the results of our test. Okay, we're back to where we started. We've got the RF generator there generating RF connected into the TR socket. You can hear the wobble there. Wires here are shorted together. Remember that magic number, 15.28. What we're going to do is we're going to get the power supply happening, disconnect this wire here, and put the 15.28 volts into the blue wire. I'm going to turn it back on again and see what happens to our wobble. Now it'll be interesting to see whether it carries on or whether it stops. So if it stops, it's the synthesizer, and if it carries on, it'll be the 3H board, which is the variable frequency oscillator. Almost time to diagnose our problem, so let's move on. Rightio, we're all set up for the test. Turn the radio on. Okay, we'll get a constant out of lock because we haven't got any DC voltage on. Okay, so next thing I'll turn on the power supply and we'll see how we go. Well, there's the answer. No more wobble. Okay, it's slowly increasing, but it's just moving a little bit with the warming up of the set or the RF generator over there, but there's no wobble, as you can hear. So the 3H board is generating the variable frequency according to the DC voltage, and the wobble's gone. So unfortunately in my case, unlike some or most Hollywood movies, we're not ending with a happy ending. We've got a faulty synthesizer here, which is yeah, disappointing, but it's a fact, guys, and got to deal with that fact. So let's have a look at what we might be able to do here. Yeah. Well, there we have it. Verdict's in. Synthesizer shot. What are the options? Could change the synthesizer. The chances of me getting hold of a synthesizer, very low. The cost to get it here into Australia, very high. The success rate of changing a synthesizer, probably low. So putting all that together, I'd have to say that won't happen for me. Normally this set would be dead. This would now become a spare set. I'd use it for bits and pieces for my other Clansmans, pass the parts on to other people, etc. But there's been some developments, and if you check out my video on YouTube titled Clansman 320D, DDS VFO conversion, I've got the option to remove the synthesizer and the 3H board out of this set and replace it with a digital DDS VFO and turn it into a digital front-end tuning Clansman 320D. Just so I happen to have one here next door, and this particular one here I only just finished a week or so ago. This was a prototype model. It's an off-the-shelf DDS that I bought and fitted. Very, very successful project. Please check it out on my YouTube channel. Yeah, it's revolutionized what can happen to dead Clansman 320s. So yes, that's what I'm going to do with this. I'm going to make this my second model as far as the Clansman 320D is concerned. I'm going to make it aesthetically a little bit more pleasing than this one here, which was simply a prototype. Although it works remarkably well, a beautiful set to operate now. And yeah, I'm very, very happy with that project. But this one I'll make it a little bit more aesthetically pleasing to the eye, and I'll turn it into an LCD type display with frequency selection done by digital means, and I'll bring this radio back to life as my Mark II model. So there you go, guys. It is a happy ending in the end. So tune in, keep your ears open for an update on this particular radio in the future. Hopefully I'll put up a video of the completed radio. But there you go. That's how you test to find out the source of the wobble. But yeah, not pleasing, because I do like the Clansmans in their original format, untouched, unaltered. They're a beautiful radio, but the option is there to bring this one back to life again, and I'll take that option. Keep it in circulation. Thanks, guys. Catch us all again for another video, another day. This is Alex here, Victor Kilo 2, Papa Radio Charlie, saying 73.